and is SpaceX's 15th human space mission since 2020, when Dragon became the first private spacecraft to take humans to the International Space Station. As Joseph mentioned, Crew 9 actually just completed a port relocation maneuver from the Ford port to the Zenith port over the weekend to make room for CRS-31 launch today. Now, as the countdown continues, let's check back with Joseph at JSC.
Thank you very much, Yome. Teams here in Houston continue to monitor the countdown of NASA's SpaceX CRS-31 mission with everything on track for a successful launch. 2024 has been a year of important achievements for the International Space Station, showcasing what's possible through collaboration, as NASA's 31st commercial resupply mission with SpaceX marks the 12th launch to the orbiting laboratory this year. And it's clear that success in space is a collective effort, built on dedication and teamwork. Let's take a closer look at how this team effort has kept the station thriving throughout the year.
The year began with Progress 87 delivering essential supplies to the International Space Station. NASA's SpaceX 29th commercial resupply mission followed, bringing critical research and hardware, ensuring support for science aboard the orbiting laboratory. Axiom Mission 3 expanded the station's research capabilities, introducing new perspectives from around the world. In March, NASA's SpaceX Crew 8 launched from Florida, each crew's transition mirroring the importance of coordination and teamwork in maintaining station operations. As the year progressed, NASA's 30th resupply mission with SpaceX and the arrival of additional crew aboard Soyuz MS-25 sustained the flow of research, resources, and explorers. Progress 88 reinforced the station's supply chain, maintaining momentum for new scientific discoveries. As summer arrived, Boeing's Crew Flight Test marked a key milestone in human spaceflight. And Northrop Grumman's NG-21 mission delivered supplies critical to daily life and research. The arrival of Soyuz MS-26 added to the station's capability for long-duration human spaceflight. With the recent arrival of Crew 9, the station continues to be a hub of progress and global cooperation. It's a place where scientists and explorers from across our planet work together, advancing our understanding of life in space, creating opportunities for the future. Every mission this year, from cargo deliveries to crewed launches and hosting 25 residents, reminds us that space exploration is a shared endeavor. The commitment and adaptability of countless individuals, both on Earth and in orbit, keep the station thriving. As we look ahead, we remain focused on building a future where exploration continues to push boundaries for all humanity.
As we reflect on the accomplishments of 2024, it's clear that every milestone aboard the International Space Station is made possible through the dedication and teamwork of countless individuals around the world. And that journey doesn't stop there. This mission is set to deliver over 3 tons of critical cargo, including scientific hardware and samples that will advance our understanding of the physical and biological phenomena. The microgravity environment of the space station provides a unique opportunity to conduct research that can drive new technologies for deep space exploration and improve life back here on Earth. Behind every experiment, there are scientists and engineers who have spent months, sometimes years, preparing for this moment. Let's take a look at some of the science heading to the station.
NASA and its international partners are launching scientific investigations on SpaceX's 31st commercial resupply services mission to the International Space Station. The Coronal Diagnostic Experiment, or CODEX, will examine solar wind and create a global comprehensive data set to help scientists validate theories for what heats solar wind, which is 1 million degrees hotter than the sun's surface. A live Antarctic moss will be studied to understand the effects of cosmic radiation and microgravity on plants. Results could help identify biological systems suitable for use in bioregenerative life support systems on future missions. Dozens of samples will be exposed to space to evaluate material stability and to help researchers better understand the impacts of spaceflight. The results could support better design for spacecraft and satellites. Researchers will demonstrate cold welding techniques in space and evaluate sample integrity. Results could aid in the development of interior spacecraft repair methods and improve applications of cold welding on Earth. Discover more about all of the science making the journey to the orbiting lab at nasa.gov/ISS-science.
It is currently T-minus 5 minutes and 10 seconds, and everything continues to be go for launch. Coming up shortly, the transporter erector, also known as the strongback or TE, will retract away from Falcon. The TE is the large truss structure you see there.
Falcon 9 tanks are pressing for strongback retract.
Next to the rocket, you just heard that call out that the tanks are pressing in preparation
Dragon is in configure for terminal count.
for strongback retract, and Dragon is in configure for terminal count.
Dragon is in terminal count and is on internal power.
There is that call out for Dragon transitioning to internal power. And ahead of the transporter erector reclining, you'll see the clamp arms just below Dragon
Strongback lower has started.
begin to open. Now, the transporter erector is designed to transport, raise, and support Falcon 9 at the launch pad and uses its umbilicals or flexible lines to route the vehicle's fluids, power, and telemetry from ground systems to the rocket and payload until Falcon 9 switches to internal